Hey data junkies, welcome back to INST 314, Statistics for Information Science, with your host, Shawn Janzen. We're continuing our talk onto the test for independence into topic 6.2, finding frequencies expected. Now this is going to differ a little bit from how we worked with the goodness of fit, so let's buckle up and go for a ride. In this video we're going to be looking specifically at the finding frequencies expected. We're also going to be showing you with an example of how to do the test for independence and figure out if you're statistically significant or not. Future videos are going to be looking at how we can do this sort of analysis in Excel and in R. Future videos will also look at how we look with effect size and power analysis for the chi-square test. So let's get started with finding frequencies expected. In this example, we're going to be using a topic of internships to work. And the idea here is that a group of students have gone out, and some of them have obtained internships, some of them have not. And based on if they have taken an internship or not, we want to see how much they still have an interest to work in an industry that they've previously identified as one of interest. And so they could either confirm that yes, they are interested in this particular company or industry, they're unsure if they are still interested in the company or industry, or no, they think they want to go on a different route. And so since they have 3 types of confirmations and 2 types of internships, this creates a 3x2 table with 6 cells. Note in this particular case, our independent variable is the internship. Did they have one or not? And does that have an association on our dependent variable of how well they want to confirm if they want to work in that company or industry? In this table here, we have just some example data where 8 students have said that no, they do not have an internship and they are not interested in the company or industry anymore. 5 said that they are unsure and did not have an internship. 4 said yes, they do want to and did not have an internship, and so on with the yes internship column. Now, what we saw before is how it might look with if you just did a regular bivariate table. If we go ahead and add the margins, this is sort of an R speak here, if you do an add margins function, it will add for you totals in both for the rows, columns, and then give you a grand total box altogether. Chances are we're going to do this in Excel and by hand as well, but I just want you to know that there's a difference between if you just have the bivariate data with just the values for the observations, and if we go ahead and put marginal totals on there as well. We're going to need the marginal totals to help us figure out the frequencies expected. So here's how we go ahead and find the frequencies expected in a bivariate table. There's a little bit of a formula to this, and the F sub E is the row marginal times the column marginal divided by the grand total, and you're going to do this for every cell in the bivariate table. So looking at the first upper left corner, we have the student who did not do an internship and has confirmed that they're not interested in that particular industry anymore. And the way this would work then is the column marginal for this is 17, the row marginal is 13. We multiply them, it gives you a value of 156, and you divide it by the grand total of 33, which gives us a frequency expected of 6.7. Looking over to the right, students who did have an internship and said they were not confirmed that they don't want to work in that particular industry or company anymore, they had a column marginal of 16, a row marginal of 13, multiplied gives you a value of 208, divided by the grand total of 33 gives us a frequency expected of 6.3. And we repeat this process for each of the 6 values in the table. So we get expected values of 4.12, 3.88, 6.18, and 5.82 respectively. Once we have those, we can just go ahead and show another value here of the frequencies expected against the totals that we had before. Now what we need to do is start computing the chi-square. The chi-square itself for the test of independence is just like the goodness of fit, as we said before, where you start taking the frequencies observed minus the frequencies expected. So in the table up on the screen, we have the students who did not have the internship and had not confirmed about their interest in the industry or company. We had an observed value of 8 and an expected value of 6.7. The difference of that is 1.3. Moving to the right, the students who did have the internship and had not confirmed, their value, we had 5 that we observed minus the 6.3 expected, gives us a value of negative 1.3 for that difference. And moving on through the rest of the table, we get the differences of 0.88, negative 0.88, negative 2.18, and positive 2.18. If these seem a little symmetrical, that's in part because of the two-column nature of our question. With larger tables and more answers, you usually don't find as much symmetry in some of it. Now, in the next step, we square the differences observed minus expecteds. So we can just take that entire table and square every value in it, which correspond to the values on the screen. And then we can take each of those values and divide it by the F sub E. So that F sub E for the no internships and confirmed was 8. It was 5 for the yes internships and confirmed, and so on, giving us the values that appear in our tables here. Once we have each of those, we can just sum them up, and we get a total chi-square value of 2.493. Now, let's go back and determine if we were statistically significant or not. The specification, the sampling distribution, is a chi-square distribution. An alpha that we set, I didn't mention this before, but we are setting our alpha at 0.05. Our degrees of freedom are calculated by the number of rows minus 1 times the number of columns minus 1. And so let's go ahead and find the chi-square critical value. The degrees of freedom, we had 3 rows, minus 1 is 2, times 2 columns, minus 1 is 1, so 2 times 1 is 2. The chi-square critical value, we're going to go ahead and bring up on the screen a snapshot here of the chi-square distribution table. We're going to go ahead and look in the columns for the alpha of 0.05 that we have, and in the rows for our 2 degrees of freedom. They intersect at 5.991, so 5.991 is going to be our chi-square critical value. We then need to ask ourselves, is the chi-square statistically significant? Well, we obtained a value of 2.49, and our critical value is 5.991. If we go ahead and plot that out on a distribution, and it doesn't have to be fancy, you can do this just on a quick piece of paper. You can just plot out a little curve and put a mark at your critical value and then color in under the distribution to the right. That would be just like on our screen here where the red shaded region, it looks like it's at 5. It's a rounded value. So, I'm sorry, it's at 6, not 5. At about 6 is where we have that chi-square value with the red shaded to the right. And I have the blue dotted line cutting down the distribution to where it's rounded at 2.5. And we ask ourselves, is the value that we obtained, where that blue dashed line, is it inside the red shaded critical value region? It is not. And since it's not in the critical value region, we can also just do this numerically and say that our chi-square obtained of 2.49 is not larger than 5.991. It is smaller than this value, and therefore it is not in the critical region, and we are not statistically significant. We fail to reject the null hypothesis. This means that we would find no significant relationship between a student's internship and confirming their interests for future work. Always remember to put your problem back into your answer back into the context of your problem. It's not enough to just say, I'm not statistically significant. It's not enough to say, I failed to reject the null hypothesis. Put it back into the context of the problem and say that there's no significant relationship between internships and confirmation for interest of future work. And with that, I'll see you all in the next video.